Hi everyone. Last time, we constructed the user database and successfully displayed the user information to the chat view. Our app is functioning, but the way it downloads data is inefficient. To see why, let's run the app and see. We'll pay attention to the downloading process and see what's going on during this time. You can see that when the app is downloading data, the UI is not responsive. This means the UI is blocked during this downloading process. All right. In this lecture, we'll use something called Grand Central Dispatch to fix this issue. All right. The reason for this blocked UI phenomenon is when the app is launched, the system creates a thread, which is basically a series of executions. It's called the main thread. And all of the UI related stuff is performed in this main thread. By default, the system provides us with a serial dispatch queue where the main thread is executed. Here's an important head up. All UI related tasks must be executed here. All executions in the main thread are performed sequentially because the queue is serial, meaning that at any time, only one execution is performed in this queue. That's why when the app is downloading data, we can't access the UI stuff. And so the UI is completely blocked. Fortunately, there's a way to overcome this issue. Besides the main queue, the system provides us with some global concurrence queues that we can utilize. Precisely, we can utilize these queues to handle heavy tasks which are not directly related to the UI, so that these heavy tasks don't interfere with the UI-related tasks in the main thread. And also, we can do that because although on the main queue, at any time, only one single execution can be performed. The computing and memory resources required to perform these tasks are really not significant. And our multiple core iPhone and iPad devices still have plenty of resources for us to utilize. All right, before we can use the idea that we handle heavy tasks on other threads other than the main thread, we need to find out what task is a non-UI heavy task in our application so that we can push it to a background thread. By the way, any thread that is not the main thread is a background thread. All right, because the UI is blocked during the time the app is trying to download data, so somewhere in this observe message method, there's a very heavy task. Precisely, it probably takes time to download data from the file URL and convert the data into a JSQ-friendly format so that can be displayed to the chat view. There are multiple steps involved in this process, so let's find out exactly which steps are time-consuming. To begin, let's just find out how long it takes for the app to download and process each message. So let's do a quick test. Remember that each snapshot is a message data. It's the data associated with a single message. So to find out how long it takes for the app to download and process a message, we'll set the time when the app starts downloading this message. All right. This is the time, the starting time to be precise. And then we find the time when the process is complete. Then the difference between these two is going to be the time it takes for the app to download a text message. And let's print it out. We'll use string interpolation here because we'll print some more text too. And to make things clear, let's say this is a text message. All right. And we do the same thing for photo messages. All right. And for video messages. All right, let's run the app. Again, we want to find out, or we're trying to find out, what steps are heavy in the downloading and processing data process. All right, you can see in the console that it's very fast to download and process each text message and each video message. And it's very time consuming to download and process a photo message. It's kind of counterintuitive. You might think that it would take more time to handle a video message than a photo one. But in this case, handling a photo message is in fact a very heavy task. So let's see why. For both photo and video, we will start from the file URL and the NS URL referring to the media file on the database. But for each video, we directly convert the NS URL to a JSQ media item. Whereas for each photo, we must convert the NS URL to an NS data. And then to a UI image before we can create a JSQ media item. So intuitively, the problem probably comes from here. All right, so let's find out of these two tasks, NS data and UI image conversion, which one is a heavy task. It can be one or both of them. So let's print out the running time for both of them. All right, let's say UI image here to differentiate with the other print commands. All right. Note here that we're calculating the running time for the UI image command by comparing its complete time to the start time. All right, let's see. All right, so start from the starting time, and it's very time consuming to convert an NS URL to an NS data, and it's kind of fast to get a UI image from an NS data. So getting a UI image from an NS data is not what we need to worry about. The NS data conversion task right here is actually very heavy. It's the one blocking the UI, so we need a proper way to handle that task. So the idea is we will perform this heavy task somewhere else other than the main thread or main queue, and reserve this main queue for UI tasks because, again, we have to. So we will dispatch this task, the NS data conversion task, to somewhere else other than the main thread. This method takes two parameters. The second parameter of the method is the block with the tasks that we want to perform. So we'll put the NS data task in here because we're pushing our heavy task to somewhere else. Intuitively, the other parameter of this method should be that somewhere. By default, besides the main queue, the system has another 4 concurrence queues that is globally available for us to use. And we can access one of these queues using the dispatch get global queue method. All right. This method takes 2 parameters, but really just one of them is meaningful. The second parameter is just a dummy one, which is always 0. And the first parameter can take one of these 4 values representing the 4 concurrence queues. This queue should be used for user interaction tasks, which, if of highest priority, meaning tasks on this queue will be considered more important than those in other concurrence queues, and so on. Our task is kind of important, so we'll use this highest priority queue, but before running this task, we want to stress a point that we're trying to perform this task asynchronously, meaning after the system dispatches the block. It doesn't wait for the task to be complete. It'll go ahead and move on to the next execution in the main thread. That means the data might not be available when this command is executed. That's why Xcode complains. So we need to call it after we get the data, which is inside this block. And also call this JSQ media item method after we got the UI image. But we have plenty of this photo, so we'll this trick instead. We'll initialize this photo in the main thread without any data because we don't have a UI image. So this is a kind of a blank JSQ photo media item. All right. And then in the background thread, after we got the UI image, we'll encode it into a JSQ media item. Before running the app, let's confirm that because the NS data task is heavy, It'll finish after the tasks in the main thread below are executed. Again, the dispatch thing is asynchronously. The system won't wait for the dispatch tasks. So this print command will be called right after the system dispatches the heavy tasks. The system won't wait for the asynchronously executed tasks. What we expect in the console is this print command in the main thread will likely to be called first. All right, let's see. It's indeed called before the heavy tasks are finished. Actually, it's called for every message, even before the data handling stuff for the first message is finished. So this is kind of asynchronization stuff. That's why before we move this snippet inside this block, Xcode complained. Because the data and the UI image is not available when we were trying to access them in the main thread. All right, you can see the waiting image right here on the chat view. It's kind of a default thing for blank JSQ media items. It's basically initially in the main thread, we created a blank JSQ media item. And then the following tasks in the main thread are called before we get the data. So when we show the message to the chat view, it's still blank. And that's why we got this default picture. It also means that we haven't been able to display data when we finish handling them. All right. Oh, the reason is whenever we have new data and we want to display them to the chat view, we need to reload the table view. In the main thread, when we reload the table view, we haven't had the data and the JSQ item is still blank. And then when we have had the data in the background thread, we haven't reloaded the chat view. That's why the photos don't show up. So to show the downloaded data to the chat view, we simply reload the collection view. All right. New data will then be displayed to the chat view, and old stuff will stay there still. All right. All right, let's clean up the code a bit. Delete all unnecessary commands we used before. All right. Let's see. Now let's recall our important rule. UI tasks must be executed in the main thread. So, yeah, we're gonna get an error. The reason is we reloaded the collection view, which is a UI task, in a background thread. Precisely, we're not accessing the UI kit stuff in the main thread, which might cause unexpected issues. That means it's not proper to perform all these tasks in a background thread. By the way, we can check what thread we're in by calling the current thread method of the NSThread class. All right, so let's print something out to make it a little bit clearer. All right, let's see. Is this a background thread? All right, we also want to print the thread itself. So let's use string interpolation with this command inside. Let's also print out the main thread to see what it looks like. Is it the main thread? All right, let's check it out. Actually, the app still won't work because we haven't fixed the bug. It's likely that we'll get that error again, but it doesn't really matter because we just want to check out the threads. So we got that error again because we're updating the UI not in the main thread. But let's see what the threads look like. All right, so here's the main thread, which was printed first. You can see its name here. All right, it's caused by the printing in the main thread. All the stuff here are background threads, and the code is not acceptable now because UI kit stuff must be performed in the main thread. That means that the UI tasks we're performing need to be dispatched back to the main queue. As before, to dispatch these tasks, we'll use the dispatch async method. Recall that the method takes two parameters. The second one is the block with the tasks we want to execute. And the first parameter is the queue where we want to execute these tasks. All right? Because we want to perform them on the main thread. So we need the main queue, which we can get using this dispatch get main queue method. By the way, let's print out the current thread to see if we're indeed in the main queue. All right. If there's no typo or stuff, the app should work well now. You can check that the UI is not blocked during the data handling process. By the way, we're in the main thread indeed when we're reloading the table view. All right, let's see. You can stop here, but we can do a little bit better. Like when the chat view has a lot of images and users scroll the view really fast, you can try it yourself. Because of cell reusable stuff, sometimes a cell might end up displaying a wrong photo. It's because then the app needs to download the photos again when users scroll the view. And it takes time to handle data, so some cells might end up displaying a wrong photo. So a trick to overcome this issue is that we save the process data temporarily, so that we don't need to download them again like that. To do so, the first step is to define something to hold the processed data. So let's call it a photo cache. This will be used to hold all the downloaded photos. We can use an NSCache object for this. It's kind of a dictionary. Because we start with the file URL, we'll use file URLs as keys of this dictionary to look up the processed photos. So the corresponding values would be the JSQ photo media items. All right. So the idea is, all right, let's see. After we got the file URL and loop up the corresponding JSQ photo in the cache by using the object for key method with key is the file URL. If this is not nil, meaning we handled it before, then we don't need to download it again. Otherwise, we'll download the data from this file URL. All right. Now, before we can look up data in the cache, we need to, once we get the file URL, if its data isn't in the cache before, then we handle the data. And then we push the handled data to the cache by using the setObject method of this photo cache. With parameters is the process photo and the URL we started with. The URL we started with right here. Now, next time when we look up this file URL, if its data is in the cache, we'll simply get this photo and then simply display it to the chat view by reloading data. Again, we need to reload the chat view anytime we want to display new data. Finally, this JSQ photo should be the value of the cache corresponding to the current file URL. So simply get the value, name it cached photo, and to be safe, convert it to a JSQ photo media item. All right. Okay. And then assign it to the photo. By the way, before now, we haven't tried to modify the photo, so we make it a constant. But now we want to modify it. We need to change it to a variable. All right, good. I think we're good. There's no bug. The app is running, and it's working beautifully. All right, so a few things you should keep in mind. All UI-related tasks must be executed in the main thread, otherwise unexpected things might occur. If any non-UI heavy task is blocking the UI, we can push it to some background thread and perform it asynchronously. Then update the UI in the main thread when the data is ready. Finally, asynchronization is hard, so we better use well-written third-party library. This lecture helps you understand materials so that you can use those libraries properly. Well, we'll do that next time. See you then.